Okay, start from the beginning, please. We are recording.
All right, so we just merged the refactoring branch that I was working on into the L3 branch. Basically, what it does is it splits up the type that we had for the AST into two separate types, one for clauses and one for expressions. And the difference is that a clause appears in the top level of a file, so you have declarations and queries, and an expression is like a variable or a functor. So basically variables and constants, but we only have one type of constant at the moment.
Uh-huh.
Uh, I had a merge conflict here. I added the multi-declaration to the clause, and I also fixed the preprocessor that we already have to take the new type because it has a different name. But if I do a Dune exec Karuta, it runs. It has a runtime error in the program that we're trying to run, but it does compile. The types match. Everything is
Oh,
okay
but
on that front.
it's having a segmentation fault because we still haven't generated the correct code.
Yes, yes, that's what we're going to do.
Yeah.
That's what we're going to do. Just one thing. Should we split this up into the preprocessor output and the parser output types already?
Yeah, that's what I wanted to ask you. I understand that there may be some benefits in doing that for sure, especially when you add optimizations via the preprocessor. But I don't know if we need this right now.
The main thing is I don't want to have to deal with both declarations and multi-declarations in the code generator actually.
No, you want to make a declaration a special case of a multi?
Yeah, basically the parser spits normal declarations, right?
Yeah.
Multi-declarations is the output of the preprocessor, but the way it's written right now, it actually has a mix of multis and normals, I think.
Yes,
Yeah,
if you don't have repeated repetitions on declarations, the declarations that are single, they will continue to be single declarations.
yeah. So I was thinking we could split this up into like, well, what's the best way to go about this? Like something like, well, the clause type would actually lose this branch, and we would
Yes.
have a decal and a decal list to make sure we have at least one, right? And then
Uh,
we would have
wait.
parser clause, which is just what we had before with normal declarations, individual ones, I mean.
Yeah, that's understandable. My problem is that multi-declaration thing there is kind of like give me anxiety.
Technically, if we have a guarantee that we're going to have at least one declaration by doing this, I don't think we need this, to be honest.
Man,
Uh,
there is something
although,
there is something in Haskell called the non-empty list type. Does OCaml support something similar?
well, that's basically isomorphic to this. If I get rid of these two, like if we ignore these two members here of this tuple, this is basically isomorphic to the Haskell non-empty list.
Yeah, but it doesn't cringe me. That's the difference.
But it's literally semantically the same thing, Lemus.
It's a feature.
Of course, Magget does say that. Of course. Uh, let's remove the tag and the arity from the multi-declaration because I agree there's no purpose in having the tag and the int if you're gonna have to have the first declaration. It's just cringe to have like, oh, to guarantee that this is a non-empty list, let's like uncons this shit.
Uh, well,
Um, wait a, yeah, yeah, but here's the thing. Instead of having a multi-query, let's do just a like what would be the
I
semantics of that conjunction? or
Conjunction,
disjunction?
yes. It
Okay,
needs to
conjunction.
match both, all of them. It needs to match all of them.
Yeah, so let's just call this conjunction instead of multi-query.
But this is the distinction here is between a query and a declaration. Actually, that's what I'm trying to highlight.
No.
But the main reason I changed this tag is because there was a naming conflict with this constructor here.
Nah, that makes sense. But I would put conjunction in there. But we have to implement that semantically, so never
Well,
mind.
query conjunction. There we go.
Okay. Remove the tag and the int. Let's remove that because we can extract that from the declaration anyway.
Actually, name as tag elements expression list arity int elements func. What's a decal actually? Has a head and a body. Has a head and a body. Yeah, we don't need this. Technically, we can make this safer by splitting the types up differently, but that would be more work.
Okay, so now what we need to do, we need to change. Probably, yeah. Let's just say ask the compiler to tell us. Okay, so the preprocessor is wrong, and the parser MLI is also wrong. MLY, by the way.
IST clause T. Oh, actually, that's relatively easy to fix. Parser clause, and the T is actually the parser clause. And then if we go to here, this is parser clause.
Nice. Okay, now the preprocessor and the register allocator are complaining. Let's fix that.
Now the preprocessor is going to take an AST group clauses. Yeah, group clauses. Needs to take a parser clause list and output an AST clause list.
Yeah, but the first function is also broken, the from declaration one.
From declaration is going to take an AST clause and return
Not
an AST
clause, an
decal. That's
AST
going
parser
to be a
clause.
parser clause now.
And we need to check. Yeah, there's probably also some other wrong stuff, I believe. Well, that's the compiler. Like, LSP may be going nuts anyway.
Hmm.
Okay, let's go. Okay, so this variant pattern is expected to have type AST clause. There is no constructed declaration with that. In the end, oh, of course, line
That's
14.
the register. Oh, that's the register allocator actually. We still need to fix some stuff in the preprocessor though.
Wait. No, but I am reading the preprocessor, but I was reading a different error. So line 14, change that to parser clause.
Line 14. Compare clauses. Right.
Yeah. Okay, that's improvement. The group,
Multi-mapper though, it takes a group
yeah, it
which
should
is
be parser.
actually.
Should be parser. But now the singleton. Um, wait a moment.
You know, actually, we may need. It may be better to do a helper for this. If we do uh, let parser to, well,
To compiler?
parser to compiler, I guess. Takes a parser clause ast dot parser clause and outputs ast dot clause. And what it does is match with an a, if I can type, with if it's a declaration with a decal, then um, we do a multi-declaration with the decal and an empty list. Otherwise, if it's a query with a decal, well, actually, it's not a decal, right? It's something else.
It's a functor.
Yes. Query is a functor. Yes, you are correct. Mul well, query conjunction with the functor. And why is this complaining? Right, because this needs to be like so.
Yes.
And then we say parser to compiler X, right?
That works perfectly, actually. Yeah. What's the problem with that? Can you go to line 30?
Line 30. Oh, right. This actually needs to be first.
Yeah, first there. And then
Map
now we
from
only have the
declaration.
33 now, which is printing the clauses. Oh, it's because the show clauses is wrong. Yeah, I understand. Yeah. Actually, just remove this. I don't think we need this anymore. Remove this print.
Show clauses in clauses.
Yeah,
Which
the
one?
show
Oh,
clauses are
that's
expecting the compiler clauses. But we are just doing. Yeah, I don't think we need to create that function.
yeah. Let's remove that.
And I also think we can just pick line 34 and return it. We don't need anything else. This was just for debugging purposes.
This is just for debugging purpose. I'm actually well. It's not gonna build.
Yeah, but
Let
let's
me
just
clear
fix
this.
this file. Yeah, now it's just a registry allocator. Just keep lines 34. After line 32, just keep 34 and remove everything else. Nice. Okay, this is
Oh,
it
it
for the.
actually put this in a single line. That's not great. There we go.
Yeah, so this is the preprocessor now. That's great. I like it. Let's now do the registry allocator.
This shouldn't be too difficult because, well, actually, be. This is the part where we actually do the thing, right?
Well, that's not where we do the thing, but because the registry allocation is the same.
139. Allocate top level.
It's because there's no declaration there anymore. We need to do the pattern matching on multi-declaration and query conjunction.
Oh, this is easy.
Yes.
This one though is
Oof. Okay, okay, I see the problem. But I also think I know the solution. This pattern matching is wrong. Just put declares in there, like declarations.
oh, this is not actually the head and the body, right? This is the
This is the first. This is a pair, right? So get rid of the record, and then there's the first, and then there's everything else. Yes. Then I think we need to do that in a let, but it's going to be first dot head and first dot body, and we grab the result of that and do a fold with everything else.
That's not quite right though, because actually
Why is that not right though? I'm confused.
I think, if I recall correctly, we still need to allocate the registers for each clause of the declaration individually.
But that's what I said.
Allocate declaration head and body. Well, this will actually be
First dot head and first dot body. The result of that we put in a let binding, and then we fold the rest of them.
we would actually need to map the rest of them.
That works too. The fold would be constructing a list anyway.
But we have a problem because the definition of t is that it's going to. Oh boy, this is actually going to return a list of t in these cases.
Okay, so the fold is now better again.
No, it's not better. The fold is wrong. It needs to be a map.
I don't understand why it needs to be a map actually.
Because we don't want to allocate the registers for all of them together. We still need to do them separately.
That's what I said. Like the fold, the folder function inside the fold, it would be doing allocate declaration inside.
Yes, and then what we do with the because like this is going to return this allocate declaration is going to return a t, right? Which is the this type, which is a register allocation essentially, right?
Yes.
Uh, that means if we do allocate declaration on each declaration here, we're going to like get a list of t's, right?
If you do a map,
If we do a map.
but I'm not suggesting a map.
Okay, then how do we fold this thing then? We can't because this is going to, if we do a fold, we're going to mix the register allocations for the different bodies, which may have different variable names.
That's not necessarily the case. You are assuming that you're going to keep updating the accumulator throughout the way. We can reset the accumulator throughout
But
the
then
way.
we're going to have a wrong allocation that's going to be used for all of them, but is only valid for the last one.
Actually, I take that back. We would only have to care about. Go back to the T definition, please. My understanding is that the only thing that matters for like after you allocate everything are the registers and the permanent variables. Actually, not even that, only the registers. Am I wrong?
We do need to know how many X registers we have actually. Do we? Don't we?
I don't think we do, man.
Hmm. We're not calling this
We are definitely
anywhere?
calling this,
Oh no, we are. It's just LSP being crazy.
of course. Yeah, you see line 34. Line 34 grabs a form, then it,
Lemus,
yes,
this is correct, but um, this is correct because we're only dealing with one declaration here. If we do what you propose and say, okay, we're going to fold, we're going to ignore everything and just grab the last one, then we're going to use the register allocation for the last body for all of the bodies.
um, yeah. Well, we could. I think we could have fixed that what you just said, but because everything is, yeah, every the pipeline is organized, folding over each declaration individually,
Hmm.
and that's kind of fucked.
Actually, there's an easy way to fix this now that I think about it.
Go for it.
If we say that this is a T list, right? We can
Well,
say this is a singleton, and this is
yeah, no, but that's a problem, buddy, because the compiler is under a different assumption.
why
Because we just showed me.
allocate declaration, but we're changing stuff right now.
No, yes, but we're gonna have also to change the compiler, not only the code generation.
Is this not list map?
No, this is list map, but this is not going to work because this function takes two arguments that are not in the declaration.
Oh, right. This needs to be.
I'm actually considering changing that to actually receive the entire declaration.
That might be wise, actually. Let's do it.
Yeah, so instead, wait. Yeah, just
Mm,
just do the destructuring on this instead of receiving the two separate things, the head and the body. Just receive the declaration and do the destructuring. Done.
head and body. Instead, we're going to do this. Well, actually not this. This, right? And this is
Yes.
an st.deco.
Declare. Yeah. And then you can get rid of that. There's probably
Uh,
something wrong.
is this messed up? It looks messed up. Oh, actually, head equals this. Now it
No, 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 no,
works.
no, no. But I think the element. Wait. No, that's correct actually. If you want to call the head as well, I think this is okay. And now this is wrong because you need to pass the first in there and
And this is
just
just,
map a lock declaration.
there we go.
Yeah.
And this is not great.
This is very bad. Okay. Can you
There we
try to
go.
compile this and see if the registry allocator is now fine? It
Now
is,
the code gen is broken,
which is
which is
expected.
expected,
Yeah,
yes.
but the compiler is also very broken, actually. Why is the compiler not breaking first now that I think about it?
I mean,
The code generation, this is broken, right? Because there's no declaration of line 26 happening on line 32 because declaration is a parser clause and we are saying it's coming a list of clauses. How is this not breaking?
probably because this is eager, like eager evaluation order in the type checker. It's
Okay.
breaking first there, I guess.
Okay, that actually makes sense.
I'm just guessing. I could be completely wrong and it's breaking for an entirely different reason
Yeah,
in
but
that place.
I would bet on your guess. Okay, so now we have the generate, which is also a fold. Well, recursion.
Oh, this is easy. And then declaration. Uh, okay, we actually have different treatment for facts and for non-facts. Is that a
Yes.
problem?
I think maybe. I think we can do the 299 one very easily. So this should pattern match on a singleton, and then everything else is the same.
Uh, okay, and actually this is the place where we needed to change the code generator anyways, because we need to add treatment for when we have more than one thing here, right?
You mean the facts one?
Like this, and like
Yes, this is the
move
place where we need to do that. No, 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 but that's not correct. 309 should have the declares, not empty list.
309, but we're dealing, hmm,
Otherwise, these pattern matches are redundant.
they aren't actually.
Oh, I take that back. The body of this one is also empty. But
The
I
body
think,
here is also empty, yes.
yeah, yeah, but this is the problem. This is not exhaustive now.
No, because we are not dealing with any case where there are other clauses here, and actually I don't think this is the proper way to do it either. Because, uh, like, okay, we need to say, probably better to separate a helper for declarations actually.
Yeah, probably.
Like, generate single declaration, which is going to do what we're already doing, right? It's going to take deco. It's going to take ast.deco.
Well, not really, actually, because I think we should keep the pattern matching on 301. I think we need to send only the elements. Am I wrong?
No, 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 no. Hear me out. If we go to the book, what's the difference between having a single declaration and having multiples? A single declaration are going to keep doing what we're already doing, okay? If we have more than one, the first one we need to emit this try me else first. Then we emit the code for the first clause. Then we emit
The trust me. Yeah, these
No,
function names are great.
then we emit retry me else's for everything except the last one, and then in the last one we emit a trust me. Right? But the case where there's only one clause is actually identical to the previous one, and we're going to need to reuse it for each step. Here, here, and here, and
Wait,
here.
so you're
See?
saying that the singleton case is only a try me else?
No, the singleton case, there's nothing here. It's just the code for the first clause, and that's it.
Yeah, so no, but I was talking about something different, man. Go back to the code.
Go back to the code.
I'm telling you, so this function that you're creating, generate single declaration, is that going to be the body of 302 onwards?
Yes,
So in that case, I think we should not receive a declaration. We should receive only the elements.
but no. We're receiving a declaration because we need to take care of these two cases, the fact and the predicate case.
Oh, so
Well, a
the
fact is
single
a kind of
declaration will be
predicate.
for facts and the clause and the predicate.
Yeah. If we have a body or not, we're going to treat it differently.
No, okay then.
But we're still only handling a single declaration here, either way.
Okay then. Yeah, so just keep it as that and do the pattern matching and call it a day.
All right, so we need to receive this thing as well, right?
Yes, actually. We need the store and the allocator
Uh,
and the generator for that matter.
and this actually comes first. This is the first argument for everything, if I recall right. Or is it the
Yes.
last one?
Yes, this is the first thing for everything.
Okay, so actually, this comes first. Then we have a declaration. And then we return this thing.
Yeah, which is the same as before, but and that's the thing. I was wondering about maybe making this a type because this is such like it's annoying as fuck.
Equals function. Is it function? No, we don't need to do that, right? We
Yeah,
need
we don't
to
need. You
do
only need to do that if you want the type signature to be completely like decoupled from the body.
match decal with, not decals, plural, singular. Uh,
Just copy paste from down there.
right. If we have this case, then we do this. Otherwise, we do this.
Yep. Try to format this code by the way because it's probably horrendous.
Just one second. Let me just be thorough. If we have a single declaration, then we call
Generate
generate
single
single
declaration.
declaration with the decal,
Yeah,
and we
but
need to pass the triple there.
yeah, so the generator, the allocator,
Let's
and
follow the same pattern we had before with the
pipes.
pipes.
Yeah, but
But
now
actually,
yeah, but now it's a
for that,
problem because now the order is wrong.
now the order is wrong. Yes.
Well, we can change it there, if up there if you want.
Yeah, let's actually do that. This goes after this.
And the type, yeah, the type signature. No, that's correct.
And then this, we're going to have to deal with the other case later.
What the heck
And
happened
this
there? No, 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 wait, that's wrong. Go to 315. That's screen.
315. Oh, this.
Yeah.
Yeah, that's messed up. There we go.
Okay. Okay, this is progress then. So now we actually can do generate multi-declaration. Nice.
Yeah, now we can do that.
Aha.
So,
Okay, code generation, new code generation.
new code generation indeed. Multi-declaration. where we have the first and then we have the others.
Now let's keep it consistent with the preprocessor. Let's call this decals. Oh, not preprocessor, register allocator. Okay, so here's the thing. We know that there must be at least two in here. We know that, right?
Right, because we already dealt with the case where decals is empty, so this is guaranteed to have one element at least, and this is another one.
Yeah, so we're gonna be doing at least a try me else and a retry, correct?
We're going to do at least a try me else and a trust me, actually.
Yeah, no, that's true. That's true. If there's only two, yeah, yeah. Uh, okay, so let's add the instruction then. So look at line 310. Let's actually do let instruction first.
We don't really need the store to add an instruction, the allocator to add an instruction, right?
Yeah, no, we're gonna just do the tuple there, the pair.
Oh, but actually there's a thing. We need to... Oh, John changed his picture.
Yeah.
We need to remember the addresses of these instructions so we can fix them later.
Um, wait. Well, I remember something about that, but I don't remember the details. So, what are we gonna put on L1, for example?
Well, we need to emit the instruction here to reserve this space, and we can use a dummy value for L1. Then we emit the code for the first clause, and then we know, okay, the next empty space where add instruction would add an instruction is L1, so we need to fix the original try me else with the correct value for L1.
Okay, so go to the machine.ml and let's change that because that's wrong.
Machine.ml, what do you mean?
Yeah, I think I put it in integer there. It should be an option. Yep,
Machine...
19.
No, but this is actually correct. This is not an option, this is an address,
This is an
which is an
option
integer.
because if we're gonna put a dummy value in the beginning.
We can just put 0.
Man, are we doing C now?
We can
Come
put
on, bro.
-1 because there are no negative addresses, and then if we have a -1 somewhere, we know that's wrong.
That's not how you do. Okay, that's not how you do typing properly, but okay.
If we actually wanted to do this properly, this would be an address type, but we actually can't. We would have a separate type for an in progress, well, a mid compilation store, well, because we need to, like, when we actually finish compiling, this will be an address, but during compilation, this may need to be a placeholder.
I'm gonna concede because it's gonna be just for the code generation. So
We can actually put any other instruction because we need to fix the value at this address anyway. So we could put something like, I don't know, placeholder,
that also works.
right?
That's yeah, but that's gonna. Oh no, go back. I have a
No,
pitch.
no, no. Okay.
My pitch is that if we put a placeholder here, we're gonna have to match that in the evaluator to because of exhaustion, exhaustive pattern matching. Do you want to do that there?
You know what we can do instead? Let's just put a halt there.
Okay, okay, that's good.
Because hear me out. The only places we're going to put halts are, well, right now at least, right? The end of the query,
Yeah,
because then we finish the query, so we have to halt.
yeah,
And we're putting a safety halt after we compile everything.
yeah. Also yes.
Which means if there's a halt anywhere else, we know we missed a placeholder.
No, no, that's okay. That's okay. But I prefer this instead of adding the placeholder there. So let's do it.
Okay, let me go back to the code generator. So
Yeah, so just remove the allocator from there and let's do pipe add instruction and then you put the cell.halt um, placeholder, yes. Then you do another add instruction and now we're gonna have to add the
Actually, we need to do fun with the generator
and the store.
and the store.
And now we need to do something about every other one, right? The other
No,
declares.
no, this is the beauty lemons. We can do generate single declaration. Oops. Generator allocator
And break the line,
store.
please.
Break the line.
Yep.
Probably going to put a line break here as well. Generate single declaration with the first one.
Yeah, but I'm kinda. Wait. So we put the halt. That's gonna be the try me else, right?
Yes.
Then we
Uh,
do the single declaration that we'll do. It won't do what we need.
we actually need to save the current address -1 here, which is saved in the generator, I think. Terms, variables, initialize. Actually, is it in the store?
I think it's no. I think it's in the p register. Go back to the add instruction function, please. Yes, it's the p register. Look at line 40.
Okay, it's the p register in the generator.
Yeah. So you do p register -1 probably.
So as generator,
Yes.
p register semicolon underscore,
Yes.
and then
I'm still confused though. The generate single declaration won't do what we need to be done. What needs to be done?
why?
Because if you go back to the book, please. Yeah. So here's the thing. My understanding is that the halt is a placeholder for the try me else,
Yes.
and then now, okay.
Mm,
So you interleave them. That was my
yeah,
confusion. You
yeah, we're
interleave the
interleaving
sheet.
because yeah, the
So
same
your plan
code
is to
that
do a fold now.
yeah, I'm going to do the try me else. Then I'm going to well, we already did this. We need to fix this to have L1 here, which we can do right now. And then the plan is to do a fold, but there's a slight problem because the final case is different from the other ones.
Yes, you need to the fold with n-1 elements.
And also, we're going to need to do this remembering business that we're doing between each step as well.
Um, I think probably that it's worth a function, a separate function for that.
That's probably the case, yes.
So what's your plan? You do the generate single. Okay, now we have to patch it, right? We have to patch the previous one.
Yes, we need to say
Go to the add instruction because I don't remember how we do the. Oh, okay.
we're
So it's
doing
a
a
code put.
we're doing a code put, which all right, because we actually have the list, the finger tree list, completely filled with empties, and then we just do inserts, edit
Oh, you're
space.
expecting to have an append here then.
No, we can deal without doing an append because we're not doing appends actually. We're doing appends only when we build the initial store with empty cells.
Yeah, I think we just need to do a store code called code put with the p register +1 or something.
It's actually p register. It's actually just the p register. Oh, but it's actually the p register after this.
Yes, that's why I said plus something.
No, but that means this is actually just the generator. And then we have to say, okay, And of course, I wish, man, this is gonna get messy really quick. Let's do a separate helper for this.
I told you.
Mm, and this is for, oops, this one is called generate single declaration, right?
Yeah.
Let's call this generate declaration and patch.
What about generate patch declaration?
Uh, I don't know. I prefer more proper English, I guess.
I'm fine with patch declaration, but okay.
So what are we going to do? We need to take we need the generator, the allocator, and the store because those need to go into the single declaration. And we
Yes.
need, oh right, that's why we need the p register from here because this is already added here.
Yes, that we need to patch it what we immediately uh, just added.
You know what kind of sucks?
What?
I kind of want to parameterize it with the instruction that we're going to add because that would be nicer. But constructors are not functions.
Yeah, I don't understand that, but
So we need to actually take an instruction concretely, which is a problem actually because we don't know how to. So we actually need a function that takes an integer and returns an instruction.
okay. Okay, actually that's a question. How do you I think we did this in the code generator above. Go above. At some point I did a function,
Uh,
I think. Yeah, check cell register.
here,
Yeah,
here.
check who is calling cell register.
Who is calling cell register? But we don't need it.
No, wait, you want to know what's how to put the type of a lambda there, right?
Which is this, right?
Uh, actually, yeah, that will work as well.
So we need to say it's a function that takes an int, and returns
ast.instruction. No, a machine.instruction. Machine.cell.instruction.
actually it's just cell.instruction, right? In this
Oh, I think we opened the namespace above, so that's fine.
and we need to give this a name. So we say let's just call it inst. Why not?
Yeah, sure.
We need the instruction. We need the this messed up thing,
Ooh. Oh, okay. This is because of the pipes. Okay.
and we need what else do we need actually?
So what's your plan actually? Why we need inst?
I kind of don't wanna like write three times the this and this and this.
Oh, okay. So your plan is to pass them as a like make that a higher order function, so then you can just pass
Yeah,
the
just
constructors in a
pass
lambda because lols.
basically, yeah.
Okay. Which makes me
Uh,
question something. Is there the cons in OCaml? I think he's in fun maybe.
that's fun.
Of course.
Um,
So let's
hmm.
see. So fun module OCaml. Yeah, module fun. I think const lives in here. Yeah, it's definitely lives in here. Okay, cool.
I'm thinking I'm thinking we are going to end up doing a fold where the accumulator has the triple that we already know and love, but it's also going to have an integer which is the previous address because we need to remember the instruction that needs to be patched, right?
I also have a question. Is it possible that after we generate the code for each clause, we're gonna have like p register minus 1 is not going to be sufficient? I think that's the case, right?
We just need the p register minus 1 to begin with, but then we can just say, okay, the p register after we finish emitting the code is the next number that we need to remember.
Oh, okay then. So perfect. Wow, that's going to
Okay,
look pretty good, all things considered.
okay, so generate declaration and patch. We need to take this function. We need to take the triple that we are going to need. We need to take the uh, address to patch, which is an integer. And I think, no, we actually also need something else. We need the declaration. We need the declaration that we're going to uh,
Probably probably ast dot something.
to emit the code for, right?
Well, I think we're already into the uh, um what's the name? Like too optimized. We don't need to have the fold correct in the first try. It's okay.
And we're going to return this, but
Oh,
also we need
premature
to,
premature optimization. Yeah.
and also we need to return the. Do we actually need to return the p register though? Because that's going to be in the generator anyways.
Let's just start writing the function and change the arguments as we go, man.
Hmm. Yeah, actually, I don't think we need to return anything else because the p register will already be in the generator. That's fine. Equals, and then we say fail with format because this is very sad, and
There
I
is a
need,
syntax error on the lambda there.
of course, of course there is. Why would there not be one?
Okay.
And it messed things up. Great. This can stay here. This can stay here.
Okay, let's actually write the fold first because then we can have a better understanding of how the thing's going to look like. So you first do the halt, then you need to patch, right?
Okay, it really wants to put this add instruction in the same line, so I'm just gonna leave it there.
Sure. So what do we do after we do the halt? We need to patch it, right?
Uh yes, so basically we need to do this. We need to say um let oh actually here's what we're gonna do. Generator store. We're going to copy this, in fact, and we're going to remove it from down there later. We add the placeholder, then um, actually, do we even need the address to patch? Because we're going to add the placeholder in here.
Well, that's what I said. Let's do the fold first because then we see how it's going to look like and understand the arguments.
Hmm. Yeah, this is probably not necessary. If we say let address to patch equals generator.pregister in, then we add a placeholder.
Then we
Then
need to generate the single declaration.
we say this is a fun taking the generator and the store, and we say
Ah, you could just copy the other line down there, but okay. But instead of
the
first, You do
Instead of
declaration,
first, this is the declaration.
then patch time.
And then maybe we need a patch function. Maybe we need a patch
Maybe a
function. I'm not
patch
sure.
function. Okay, let's describe how to do the patch. Then we evaluate if you need a patch function.
Okay, we need to do a star put, I think. Let me get rid of this for now. We're going to need to do something like star put,
Code
which
put,
takes an A, which is a cell in this case. So we're going to
code
take
put,
the code put, right? So we need to take an instruction. So we do inst of
address to patch,
not address to patch p register.
p register. But address to patch is p register.
No, the address to patch is the p register before we emitted the code. It's the one that has this instruction,
Ah, I see, I
right?
see, I see, I see.
But the label actually points to here.
Okay, so it's gonna be p register plus one then?
No, it's just p register because the p register is the next available
Yes, that makes
slot.
sense.
We're going
Okay.
to put the inst with the p register as an argument. We take a store, and that returns a store, right?
Yes.
Yeah, and that's the new store. That's all we're gonna do.
Okay, so just put that in the pipe, and then let's update the store
Um, Actually,
essentially.
this takes an address. This is the address to patch here. That's what we're gonna do.
Okay, so then put this in a tuple with the generator and the allocator, and this is the new store. Done.
Uh, okay. So we say
Fun, pipe fun, then
that's very fun.
generator, allocator, and store, and then
And
we
this
just
actually can be
yes, p register
as
here.
generator p register semicolon underscore.
Yes, and then we return a new triplet with generator, allocator, and that code put. Okay, what's the problem now?
This expression has this type where we expected a cell T.
Wait, what?
Cell.instruction is not compatible with cell.t.
Oh, it's because the store doesn't hold instruction.
There we go.
That's okay. Man, this looks awesome. Like, come on. Okay, now we fold with this. That's your plan.
Yes, but the fact that the fold is not quite uniform is going to be kind of annoying.
I think it's
But yeah,
easy though. I think there's a function called last, and that decouples the last element for from declares. Here's my proposal. We
okay.
we do the first, and then let's call the function right now, generate declaration patch with the first using the try me else. Then let's pick the declares, do a pattern match on, well, do something to discover if there's more than two elements on it.
You know what I want to do actually? I'm very tempted to just say screw it, take this decals, turn it into a finger tree, and pop the last element, and then we can fold just the middle part.
But that's what I said. Well, I didn't say it directly as you said, but what I meant by identifying if the declares have two or more elements is because then we pop the last.
The problem with just popping the last is, well, this is going to be linear either way because we need to convert it to a different type.
Yeah.
Uh,
Let's pop the last. I think batteries should have a function. The only problem is that if we pop the last, we need to see if declares is now empty because there may be only one element in there.
We don't actually, because we're going to fold with an empty decals with the middle list, and that's not going to do anything, which is exactly what we want.
Well, yes, in the case of using using the fold, that's enough. Okay, so what are we using? We're using bat finger tree. I forgot.
Uh, yes, we're using finger trees. We
Are
need
you
to
sure?
do.
I think declares is a list.
It is a list, yes, but we need to. Well, we need to pop the last element, right?
Yeah, but I think bat list may have something. Let me check. And then I do last. Uh,
I doubt it,
there is a
because
last
last.
function. There is a last
Oh,
function that does exactly what
oh.
we want. But I think what you want to do is a split. Um, and that may be a problem.
We can implement that ourselves actually.
Sure.
Split last,
Yeah, that's a good name.
which takes an A, well, let's call it L, which is an A list, and it returns a pair with,
A
hmm,
list and an A.
okay, if it's empty, that's gonna break, but that's fine because we already eliminated the empty case here, right?
Well, if you want to make this function like the best, we should return an option on the second.
Mm,
But that's annoying for our use case, so just fail.
we can do it in here though, right? And then we can make sure that we don't use it accidentally somewhere else where it's not actually safe.
Okay.
This can go here, and that's messed up in all kinds of ways.
Yeah.
This can go here, this can go here, and this can go away. In, and then we say, okay, if it's empty, um, impossible.
Yes.
If it has a single item, uh, final, we return.
Tuple, empty list, final.
And then else, if we have first colon
Others.
rest,
Yes, sure.
then what do we do? We need to say, hmm,
Um,
then we need to say actually let um, left uh, final
yes.
equals split last with the rest and in, and then we say first colon left final. There we go.
Wait, let me see if I got this. So empty, it's impossible given the 329. Well, 327 and 329. If there's only one element, this is it. We just say that this is the final. And if there's more than one, we just ask it to do the same, which is basically gonna cons the entire thing until you have only one thing. Yep, yep, this is it. Nice. Let's use it now.
And then we say let uh, middle decals equals. Oh, actually, that's not quite right. It's middle decals and
Last.
final decal, or we
Yeah,
can call it last, I guess.
last decal. Split last, and then you pass the decals in. Awesome. Now we do the
Why
fold.
is this complaining? Oh, it's because this is messed up, I think. Maybe, possibly.
I don't think that doesn't make sense. That doesn't make sense. What's the problem? Ask the compiler.
Syntax
Syntax
error.
error.
That's all it says.
Um, put the match on a new line. Yeah, put the equals back on where it was and put the match on the new line. Okay.
Like this.
Yeah, indent that. What's the problem, buddy? Am I going insane?
Maybe we need to do this.
I don't. I have my doubts. I really do have my
Oh,
doubts.
actually, maybe we need to do this instead and say
No,
no,
no.
no.
What the heck is going on? Let split last. Then we have the type of that, and then we're saying the return type. I am confused. What the fuck is going on? Can you try to compile this to see if it's a syntax error, still syntax error? It's
Still a
still
syntax
syntax
error.
error. Oh, it's I know
Yeah.
why, because that's a Haskell thing. Okay, so you need to replace the tuple with the star.
Oh, right. That's actually correct.
Yeah,
There we
you can
go.
remove the parentheses now, by the way. Not only those parentheses, I mean the parentheses in the 330.
And yeah, I forgot to make this recursive.
Yeah, but please remove the parentheses in the pair, man.
Remove the
Oh,
parentheses
it's
in the.
already did. Your formatter already did. Thank you. Okay, now we do the first instruction, generate a single instruct. We do the first, and we can call
Uh,
our function. We can call our special function.
yeah, we can call our new function, our new fancy function, generate declaration and patch, which is well, actually we need to pass the allocator as well, right?
Yes, yes. You don't need any of this. Now you
Generate declaration and patch, and now we need the
fun.
well
Garbage, garbage. Okay, break the line before the pipe, man.
before the pipe, right? Let's do it.
Trust me. So
Cell
cell
dot
dot instruction.
instruction dot try me else
Oh, try me else.
with
Sorry. No, no, not that, not that. It's the constructor. It's another try me else. I actually don't know why your thing did that. Yeah,
actually I think this is the wrong thing.
go there. Go to the instruction. Oh, well, that
Machine.
works.
Cell dot instruction dot
I think it's
try
just
me else.
cell dot try me else. I don't think there's instruction in the middle. I also don't think that's correct. I think that we don't have that. Yep, I think that's
Mm,
the way. But now we need to pass the other arguments because otherwise LSP is gonna go insane. So what are the other arguments?
well, the other arguments are
The declaration. So
uh,
first,
declaration,
and that's it because it's in a
and
pipe.
that's it
So now
because
we
it's a
fold.
pipe. Well, this is still wrong actually.
Unused variable n.
Do we actually need to do this? We
No,
don't.
I don't know what's wrong, but we don't have to do that. Can you go there just to confirm it's an integer there?
Constructor cell.transML belongs to this variant type, but a constructor was expected belonging. Oh, right, because we actually need to do cell.instruction.
No, man. Look at line 322.
There we go.
Ah, okay. The add instruction is doing that for me, for us. I see.
But we're always going to use an instruction, so actually you can put that inside here, I think. Cell.instruction.
Yeah, but now the type of that function is wrong. Yep.
And
Nice.
then you can say this is just a try me else.
Hey, I think you can remove the extra parentheses also, by the
And
way.
we can remove this.
Awesome.
Yeah, this is better. This is
This is
much
better.
better.
This is better. Now we fold.
Oh, it actually broke the line nicely. Now we fold, yes.
Ah, but you cannot pipe that because I think the accumulator is not the last one. Fuck. That's not nice. That's not nice at all. I think we're gonna have to make a lambda, man. Don't forget to. Well, you're gonna make. No, you need to put something in here, man. Are you gonna pipe?
I need to put a pipe here.
Ah, okay.
And then do
List
list
dot
dot
fold left.
fold left. This actually takes the function first, right? Which
Yes.
is well, going to be a fun taking the what does it take as the next input?
What do you mean?
Oh, right, it takes a declaration. That's right.
Yes.
Deco. That's correct.
Then we call generate declaration patch. But we replace the try me else with something, which I already forgot. I think it's the retry.
Yeah, this is the retry me else, indeed.
Man, I have a question.
Okay.
Can we swap the because you see that if we swap the declare and the arg and the ACC from the generation and declaration and patch, we can remove the lambda.
If we swap the
Ah, but that will
declaration
yeah,
neck.
but that will break the pipe above. I see the trade. I see. Okay.
We does OCaml have a flip function? Because we can use that.
Probably. Uh, again, OCaml people will hate us, but I love it. So, fun module camel. There's probably a flip in there. Let me see. Oh, there is actually. Awesome.
So what? Fun.flip,
Yeah,
right? I think.
yeah. And then you can, well, you can use the at instead of the parentheses to piece them even more.
Let's do it.
Okay, now you put the accumulator, the initial accumulator, and then the list of stuff. Damn, perfection. And then we need to use the last.
If I put a pipe here, it's going to put it inside of the function body, right?
What do you mean?
Because I want to do this
Sure. Now you
and
do
say
that.
this again, except instead of a try me else, we're going to ignore the
Yeah, there is no, no, no,
address.
no, but there is a const. That's what I was checking. Let's use it to piece them off again.
We can't do that because constructors are not functions.
That's true. Ah, fuck. Wait, but this is a constructor that is we're not using as a function. I am correct. Just do a const.
Oh, oh, we can do const
No, 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 but
from
it's inside
fun.
fun. Yeah. Damn. Does this type checks?
Apparently it does.
Damn. Oh, now the compiler is broken. But this means that the code generation is fine. It looks beautiful. Holy fuck. We even made our own
That's what.
split list.
Well, that's what happens when you know what you're doing.
Damn. We know
Doesn't
what you're
happen too
doing.
often, does it?
Man, I'm impressed. This looks nice.
Oh, I think I'm done. Man, I can't believe I could compose all of this now.
That's nice, Magita.
Look
Okay,
at this,
let's
Magetta.
let's fix the compiler now.
Look at this. It's amazing.
Yeah, it's awesome.
Looks like garbage,
Uh, of course you would say that.
which may be nice. Garbage is nice.
Okay, line 22, this one.
Yeah, most of them are wrong
So
probably.
allocate top level,
Oh, it's the last
of
one. It's the
course.
one that we were debating before.
This one. Yeah, this takes a clause and returns a T list. So this takes a clause and it needs to return a T list.
Yeah, but the 22 is still wrong.
Match
You see
LM
why?
with blah 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 form.
Yeah, but the LM is an AST clause. There's no declaration and query constructors in that. And this is already
There aren't.
like after preprocessor, so we don't have the parser stuff.
Multi-declaration, query conjunction,
Yeah,
doesn't
but this
matter.
is now also wrong because the forms, we have forms, not a form in there.
Uh, let's call it forms, why not?
Oh wait, I've said bullshit. We are ignoring the list. This is still a form. Go back. I said bullshit. Okay. Um. Yeah, this returns a T list. What's the complaint now? Can you run the compiler? Ignore LSP, man. Thank you. Okay, so now 32 is wrong. Okay, here's my question. The compiler was done in such a way that it was expecting to do recursion on each declaration. Now we're completely changing the paradigm. How do we plan on fixing that in the compiler?
Uh, hmm. Actually, you know what? We may have a problem here. We may have a problem here. The register allocator needs to change slightly more. Well, not the register allocator, actually, not here. Code generator, because here's the issue. We need to receive actually a list of allocators, not just one.
Wait, I'm confused. Oh, it's because it's not an allocator per declaration anymore.
Right.
Fuck. Man,
Uh,
that's problematic.
not really.
Yes, it is because everything was done in this file, which is the most complicated one we have so far, assuming a single allocator. Everything is running under this assumption.
Well, everything inside of here, we will only get a single allocator, but we need to take a list of allocators here and return a list of allocators here. And basically what we need to do is say, okay, we're just going to use the first allocator, but we're going to remove the first allocator when we return the triple here.
Man, that's gonna suck ass so hard because look at what we're gonna have to do. We're gonna have to change the type signature of allocate head and allocate body.
No, 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 we won't. We won't. Look, hear me out. If we say allocators, which is actually an allocator list, right?
Sure.
We're going to say,
Yeah, this should be a compiler error, so this is fine.
oh,
Allocators.
this is actually allocators, yes. And then we say, uh, actually,
Okay, I
do we
was not
need to do this
expecting that
elsewhere?
amount of work actually.
It's going to take one of these, and it's going to return also one of these. And this is just going to say, okay, we're going to ignore this one. And we're going to return generator allocators store.
I would call this function pop allocator, not swap, but okay.
Okay. I was thinking, since we're doing this here, maybe, I don't know.
Sure.
No, actually, we do need to remember this. Right, because this is actually swap allocators because we're going to, this is the interface between having a single one and having multiple ones. We're going to ignore this completely. And we're going to receive another argument, which is allocators, which is this.
I'm confused. Why are we doing this?
Because I want to do this, swap allocators with the allocators.
That's not correct because the order of the arguments is incorrect there.
Okay, we can fix that.
Okay. Uh, I'm still confused actually because here's the thing. Here's the thing. Um, what is this doing again? This is basically removing the current allocator and grabbing another one. Um, wait, swap allocators. This is not a swap. Wait, why does it call that? Because we are grabbing an allocator, removing the current one, and
We're
returning
taking a
something
list of
completely different.
yeah, we're taking a list of allocators. We're taking a triple with one allocator and returning a triple with the list, discarding the single one that we have before.
Okay, I see. I see the vision.
Then here we do swap allocators. I don't think I can. Oh, I can. Nice. And then here we say, okay, we're going to say this takes allocators, which is a list. Then to do a query, we actually say,
Damn. Damn, 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 damn. You can just use head if you want as well, man. No. Okay. Yeah, but that function is not expecting allocators, so.
it will expect allocators. It just doesn't yet.
I think it's better to just do the. Oh wait, you're gonna just pass allocators there. No, that's okay then.
And then we say allocators, which is a list.
Yeah, this tuple is getting worse, so I'm considering making a type.
Which is a list. Uh, generating a single declaration takes the list still. And actually, this is going to advance step the list by 1, which is correct.
Wait, we are kind of doing like we're kind of doing a zip, but very indirectly. You see what's going on?
Yeah, this is plural now.
Did you hear me, Marinho?
Yeah, this is it a zip?
Yeah, because we are grabbing a declaration and kind of matching it with its own allocator, but we are doing it not like directly in a sense. We are kind of doing the swap. The swapsies are the ones doing the zip essentially.
Yeah.
So it's kind of weird, but okay.
So why does it say
It's
that
oh,
this is wrong?
it's because the 3 to 24.
24.
The return
Oh,
type
right.
is
This
saying that this should be not a list,
this needs to be a list.
and now this is wrong.
And now this is wrong, but actually
But you want to swap it?
we're going to swap with an empty list for now because we're only dealing with one query at a time for the time being.
Put a to do there.
What broke? What broke?
Because you have another parenthesis by accident in there. Now it's correct. Yeah, that's wrong.
To do. Deal with multiple queries.
Okay. Okay. This seems all green now. Surprisingly. And now the
Now we
compiler
can
is
go back.
broken again.
Now we can go back to the compiler. Yes. Uh,
Allocate registers return. Yeah, this entire pipeline is incorrect now.
okay. First of all, this is going to be this is going to be a multi-declaration.
Yes.
Is that a problem? I don't think it is.
I don't think it is. Here's another problem. I don't think we need to recurse anymore. Yeah, I think you can get rid of 29. The pattern matching.
29
Yeah. I think you can just do
pattern matching.
DSs, like declares in here.
No, no. We still need to recurse
Why?
because we may have multiple multi-declarations in a file.
We may have multiple declarations in a file. That's true.
Does this work? Well, it builds.
Well, we already have the functions for it to evaluate. Let's run a program.
Just let me check something real quick. Multi-declaration, we allocate the registers, then we generate the code.
Yeah, change the name of 34. It's not a fun allocator. It's fun allocators.
24,
34, sorry.
34 here.
Yeah, this is wrong naming. It should be allocators. Yeah. Then we
Oddly enough, I think this probably just works.
well, let's run a program and see what the heck happens. Didn't
Well,
change a thing.
this was already happening before, but
Yeah, but this was
main
happening before because the code generation was incorrect.
we're in L2,
No, change to L3 then.
but L2 needs to still work, right?
Oh, that's also correct. Okay, so we broke something and then.
Let's put. There's a print here somewhere here.
Yeah. Okay. Okay,
We're going.
this seems like an infinite loop situation, but okay.
Set variable, put structure, set value. What's L2 again? I forget. right, we're calling Q, we're calling R, we proceed, we deallocate, and then we don't return. We don't proceed.
We call P, then we allocate more, get variable, get variable. Yeah, this seems that something went very wrong. Do we want to check the generated code to see if that's fine?
We do, actually.
So I would
Uh,
say go to the main. Oh, that's gonna suck ass. Yeah. Oh
Show
no.
store.
Oh no, it is in there. Okay. I'm very glad I kept those. Ah. Okay. Line 44. You need to pattern match the computer and extract the store.
Oh,
Yep. And now it's complaining still. Why? Well, ignore LSP. Just go. Unbound record
unbound
field
record
store.
field store. Right, because actually the
That
store
doesn't
comes
make.
from the compiler at this point.
Wait, what? That doesn't make sense to me. The store is
Oh
in the
no, it
computer.
doesn't. It doesn't. You are correct.
Okay, so go to the go to the halt program function and see the return type of that. LSP is fucked. Yeah, go to the machine then now and let's read what's. I think it's a store. Go to the bottom, all the way down.
T.
It's a store.
Yeah, store.
I don't understand. Actually, let's do it even better. Let's do maybe it's a module nonsense. So let's do computer and do computer.store in the print.
Apparently that works.
Ah, nice. So it is module importing nonsense.
Mm,
Here's the problem. I don't remember what was the correct code.
okay, so what are we supposed? I didn't mean to do that. Okay, so what are we supposed to do? We have ABC. Uh, B and C are both used twice, so allocate 2 is correct.
Yes.
Then get variable x3, x0. X3, x0. We're moving A to register 3, that's okay. Well, we're copying it actually.
Then we copy
Get
B to the
variable,
first permanent, then C to the second permanent.
right. Then we do a put value from, well, this basically cancels this. Then we do B onto x1, which is redundant, but okay. Then we call Q.
Which is correct.
Then Q is a put value using Y0. That's wrong.
Okay.
That is wrong.
Are you sure though? Because Y0 has the B, right?
But Q doesn't have, shouldn't have permanent variables. It only takes 2 parameters and they are just literally themselves.
I'm a little confused. I think we should do the following. I think you should stash your stuff, go to master and run the same program and let's see the output because I think I have a recollection that all of this is correct.
Okay, just real quick, let me copy this big thing here. Copy this, put it here.
Yeah.
Uh,
No, man, don't change it because then we're not gonna be able to compare easily. But okay.
How many of these are there?
Yeah, so that's probably why, like, evidence that we fucked up.
There we go. Uh, there we go. Now, what?
Oh, you're right. There's no put value in there. Is
What do
this
you mean?
master on the left? Oh no, it
No,
isn't.
that's what I just copied over to the right.
Oh, okay then. So stash it. Pull master. Check if main is running L2,
It should be.
and
It
now
is.
go for it.
We need to print the star though.
Yeah. And do the same trick. Computer.store. How did we like? If this is fucked up, I wonder how we did that. But okay. Well, I actually know how we did that because we kind of significantly changed. Yep. I don't think there is. Wait, H and F. Are we running the correct thing? Oh no, H and F comes from the P query. Okay, that makes sense.
They're coming from the Oh, well, I think I see the problem. Kinda. Maybe. Well, actually, no. That's probably not an actual problem. Where is temp?
Oh, in the other one, we didn't have the query.
We do have the query. It's just somewhere else. That's not an issue.
Oh, okay then. Okay, so we need to jump the query. Let's jump the query.
Okay, so the query is put structure blah blah blah, put structure f, and then it does a
Call to
call
P.
to p3, which is this
Down there.
call.
Yeah, it's down there. So the first thing we do after halting is unify variable.
Unify variable.
I don't think we have any of those in here.
Oh, that's because this unify variable is supposed to be one of these, I think.
Damn.
I might know the problem actually, but let's check this first. So, we have unify variable x0, x1, proceed,
That's there.
and we have that twice actually, because the two facts are identical.
Yes.
And then we have this. That's the beginning of the function, and that's what we're interested in. So allocate 2,
X3, X0 on get
x3,
variable.
x0,
Yes. Get variable on permanent.
y0 to
Yes.
x1, y1 to
And then there
x2.
is a
Those are
put
all the
value,
same. There is a put value.
but it is different. Oh no, it is not.
X,
It is not. It is X3, X0, which is correct. Then there is
then
the same
y0 to
permanent,
x1.
which is also correct.
Then we call q2. All right, then we call q2. We're not inside of q2. That's correct. And then we do y0 to x0. I messed up when I saw this the first time then. Then we do y1 to x1, which is the same. We call R2, we deallocate, and then we halt, apparently.
And what are we doing differently in the new version? After we call R2, we never called. Oh no, wait, we called R2 actually.
We're missing a proceed here, I think.
In which one? On the left?
On both. actually.
Okay, so the previous one was wrong. That's what you're saying.
The previous one works accidentally because of the safety halt after the final function. We need a proceed here.
Okay, so we discovered a bug.
Yeah,
Okay, so let's go back to our branch and do git stash pop.
git checkout. Can we
Let's,
commit what we already have though?
yes, you changed
Of course.
stuff.
Let's just restore main. That's okay, right?
Yes. Oh, but that was so anticlimactic. Like we had the everything done like properly and even pretty, but it doesn't work because there's a bug from before.
Allocate head, allocate body. We need better names.
You already said this before, and I don't have better names for these. Where should we do the proceed? Do you know? Like, do you have a guess?
It's right here,
Okay.
actually.
Okay, let's compile and see what happens. I'm so glad we did the add instruction function. It's so convenient. This seems very wrong now. Like
This is,
worse.
yeah, this is messed up. Okay, this actually went pretty long.
No, I think this is an
Uh,
infinite loop situation.
no, it is, but
And here's the problem. We don't know if it's the code generation or the evaluator at this point. But I think it's very unlikely that the evaluator will be the problem.
actually, let me double check something. Evaluator, de deallocate. E-register and store.
So close yet so
E-register,
far.
e-register. No, this actually returns. This actually returns.
Two line function. I think it's just worth remembering that we don't have the stack to do the multiple returns. I don't know if you remember that.
Yeah, that's something I was wondering about because theoretically we should have it, but we don't.
No, we don't. We already established this before. I think it's on the allocate maybe. I don't remember. There was a function that was doing some stuff, and then at some point we had a debugging session, and you said, "Oh, the problem with this is because we don't have multiple call stack." And then we identified that the book also doesn't do that. So we just said screw it.
Set variable, put structure, set value, blah blah blah. We're calling the query, we're calling the predicates, we're doing the allocates, we're doing the get variables and stuff.
Yeah.
Call Q2, unify, proceed, put values, call R2, unify, proceed, deallocate. This should return back to the query and then halt. It isn't.
Are you sure the swap allocators with an empty list is correct?
Uh, well, for the sake of our sanity, we can do.
Because like you did that, but I wasn't wondering. I don't. Maybe I'm too tired to understand, but maybe it's not empty list in there.
That shouldn't make a difference.
And well, at first glance, it doesn't seem to be the case. Yeah, we can go back to the empty list. That's fine.
There's one thing though. Uh, it shouldn't be. Well, it shouldn't affect this program because we don't have any actual multiple declarations here.
Yeah, that's the L3 program.
Mm, what are we missing actually?
What's kind of funny to me is that we introduced this by the multi-declaration thing. So I think it must be something about the new
No,
stuff.
no, 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 no. It's not. It's because the old stuff is broken, but it was working by accident because of the safety halt instruction that we are introducing at the end.
But how are we introducing the halt? I think we're introducing the halt kind like after the program is done.
We're doing it here, right
Yeah,
here.
yeah, but go there. Okay, so where are we is explicitly adding the halt? On the P register, so after the program is done.
Yeah.
Okay.
No, no, not after the program is done. After the final allocation. Well, after the final after the final instruction of the final thing that we emitted, essentially.
Oh
We
yeah.
just which just so happens to be the predicates that we are calling in the old
that's
version.
that's kind of too lucky even for us.
But because we introduced the multi-declaration, we're now reordering these, you see?
Yeah, yeah, yeah. I see the problem.
And in fact, I bet that if you go back to master and we just put this up here,
It's gonna break.
uh, it's gonna break, yeah.
Okay, but let's not do that. Let's try to use the last remainings of our energy to try to figure out.
Hmm.
Well, if it was not introduced by our stuff, it means that it may be wrong from like sessions, way previous sessions.
Actually, it's not proceed, it's deallocate, right?
Well, that's our hypothesis on what's wrong.
Uh, remove an environment frame, blah blah blah. Proceed resetting P to the value of its CP field and E to the value of its CE field. The explicit definition of deallocate is this.
Which is probably what we're doing.
Yeah. P equals stack at E plus 1, which is deallocate.
So there it is. So we
Yeah.
do a get, then we do a get again, and then we pattern match on both to see if they're both registers, and then we wait, wait, go back to the book. Uh, go back. Yeah, no, no,
Stack at
this
E
is
plus
correct.
1
No, this yeah,
and
this is
stack at
correct.
E.
Yeah, no, this is correct. Well, this we are doing that. That's what I'm trying to say. We're definitely doing that. That's tough. That's real tough.
Hmm.
How are we going to debug this? So at some point we do the proceed, And the deallocate, but the deallocate doesn't finishes the program. That's the problem, right?
Yeah, the deallocate should theoretically return back to the.
Yeah, but we don't have a stack frame. Well, we don't have a return stack. Remember that.
I think I know why. It's because we're doing nested calls and we don't have a proper stack.
Oh, so we cannot even run the L2 program then without the nested stack.
This doesn't look like it's nested, but it actually is because this is a call, right?
Yeah?
To this.
Yeah.
But then we're doing a nested call to Q and then to R.
Ah, I see. So there it's like a choose stack size. Um, fuck. Okay, search for the at sign in the book.
Let me just check.
Because whatever function uses the at sign is the function that we need to use the we need to implement this the return stack. I think it's call as well. Or maybe it's proceed, I don't remember.
Uh,
Yep, there it is. The at sign. Yeah, so call our call doesn't do that
it
properly.
doesn't.
Yeah, we don't have a stack that we keep popping. We don't have that.
That's not what it's doing though. Well,
It should be doing that.
no. Here it's saying, okay, um, this is the address of some predicate P of RTN. We're taking the address of that, right? And we're just putting it in the P register. That's all it's doing.
Yeah, but I think we had this conversation before, man. We spent a session debugging something that the problem at the end of the day was the lack of a return stack. Don't you remember this? Don't you recall?
Yes, I do.
Yeah, so where do we need to implement that? That's my problem. I don't remember anymore.
Flat resolution.
Oh, maybe it is this version of call. Maybe.
This version, yes.
Yeah, that there, that at P and at P, I think we are only having like we have a shallow stack. So you have if you have more than one call, it's fucked.
This is for facts. For facts, we do. Hmm. Actually, for facts, this shouldn't break though, because we're saving the program counter in CP and then proceed pop CP. Hmm.
Like I said, like I always say, so close yet so far.
And I think we do have it actually, like this right now.
Yes, no, we do have it like that. But there was something that we established last time that we said, hey, at some point we should have added a to do, and we just didn't, and that's trash.
We're doing the arg count because we are not using a global variable, and then p register is find functor table, which is correct. Um, when it's not defined, execution fails. Okay. Do we have another definition for call though?
I don't recall. Tutoots.
I don't think we do.
Well, I haven't read the optimization chapter, so I don't remember. Wait, and I
An
know you.
environment is pushed onto stack upon a non-fact procedure entry call and popped from stack upon return.
Hmm. Are we doing that by any
Maybe the
chance?
problem is with allocate and deallocate somehow.
I find that hard to believe.
Right, because call actually saves the previous P register in the CP register, and then allocate takes the CP register and pushes it to the stack. So it does in fact save the the thing. Huh, that's
Okay,
kind of interesting.
okay, but then why are we getting an infinite loop then? Because my understanding was that the allocate was wrong. Actually, it's looping the allocate as well, if you think about it. So, yeah, it's not the allocate the problem. There is something really fucked up in there. Yeah, we do call, then unify, unify, and that was supposed to be it. Done. After that,
Yeah, this
done.
should.
But for some reason, we keep doing unify. And you know what's funny? I think we're unifying R all the time.
We're going to this, which is. Hmm.
Obrigado.
Let me think for a second. This is 0, this is 1, this is 2, this is 3, this is 4, 5, 6. So we save a 6 there. Well, actually we save a 7 because, well, it's this plus 1 to points to here. Well, not to here, to the one instruction after the call to P, which is supposed to be a halt, but it isn't, apparently. No, it is actually.
Mm-hmm.
For good measure, it's 2 halts,
Wait, two halts?
because this is the halt from the query, and this is the safety halt that we're adding at the end of everything.
Ah, okay. I was about to wonder if one of the placeholders is broken.
Yeah, you know what? Let's
What?
get rid of this.
Sure.
Stack
I
start
didn't
equals.
recall that the halt program was a safety measure. I thought it was because you have to do it.
No, it was a safety measure actually. If we get rid of this, like, let's just remove it. Well, it's actually not gonna do anything in this version of the compiler because it's compiling things in a different order. Uh, let's just comment this out for now. Unreachable allocate.
Damn. Okay, so if you remove the safety measure, we actually reach an unreachable. That's
Oh,
fucked
this is
up.
actually doing something more than just adding the thing. It's actually also stack start is equals e register. Then store, we put a halt. Then we actually fill in some stuff here at the stack start. We put the e register here. We put the address at the p register. At the p register. Where is that coming? Oh, it's from the compiler actually.
Yep.
That doesn't make any sense.
Well, it was
And
until
then we
now.
put a zero. And then we put a zero here. Hmm.
Okay, so you don't remember why we did this.
Uh, I think we were setting up an initial stack frame, but there's not really a proper reason for that. I don't think.
No, sure, but then why we are reaching an unreachable in the allocator?
Because if we
The
go to
block
the
depends.
evaluator and we go to let allocate, it's going to say, oh, let's put, oops, 0 and 1 here.
Wait, what?
Uh,
What did you just changed? I'm confused.
I messed something up real bad here. Right, unreachable allocate, unreachable allocate. Yeah, we're hitting 0, which means there's no e register plus 2 in the store. Well, in the stack actually, I should say.
Yeah, that's fucked up.
Hmm.
Yeah, I think. Well, we did a lot of progress today. I think we should commit anyway from the stash. We need
Okay.
the next session is gonna be oh man, it's gonna be boring as fuck. But debugging session to discover where is the bug. I'm gonna have to add all those prints back. Like
Mm,
I really wanted. I love when this happens when you have an idea of like something clicked and oh I know the problem. I don't know the problem. You don't know the problem.
okay, let me just do an FMT, but everything is already formatted. Let's say, oh, actually, there's one thing we should do before we commit. Actually, before we forget. Um, it's in the code generator, I think, where in the multi declaration we do a declaration and patch, we fold, we do another one. Actually, I think it's not here. It's in the compiler. Multi declaration. We do this. We generate. We compile. We add to the functor table using the head. Oh, this is actually already correct. Never mind.
Yeah.
Okay, that's unexpected, but okay. That's good. That's very good.
Yeah, no, but aside from that, what we did today is looks pretty good. I'm a fan. I'm a fan of that code. So nice.
Well, if you think about it, a compiler is really just a very big pipeline.
That doesn't mean the code will look good. Then you know what I mean.
I'm just going to commit everything as it is.
Sure.
Hmm, let's add this back. Why not? And halt program is commented. Okay. Wrap up multi declaration
Code generation.
to do. Um,
There's a bug
Figure
somewhere.
out the bug with uh,
I'm gonna finish the recording now, by the way.
okay.